In problem number 1, they are asking us for frequency and period. So they give us 60 revolutions per minute, we convert them to revolutions per second, and that gives us 1 hertz, or the frequency. And the period is with this formula, 1 over frequency, and we substitute our values and give us 1 second, and it's the period. In problem number 2, they are asking us for velocity. They give us the data of the frequency, the amplitude. So we're going to use the formula that it's velocity equals 2 times pi times frequency times amplitude. We substitute our values, we substitute the frequency, and we substitute the amplitude, but the amplitude is given in millimeters, so you change it to meters and give us this result. In problem number 3, they are asking us for work and for potential energy. The data that they gave us is distance and the constant of K. So for work we need to know which is the force, because the formula is force times distance. So we're gonna use the formula of force that is amplitude times constant. We substitute the values and we have the force. Then we use the formula of work and we substitute the values of force and distance, and we got this result. And for potential energy, we have all the data, that it's the constant of K and the distance to the square times half, times 1/2. So we substitute our values and it gives us this potential energy. In problem number 4, they are asking us for velocity. The data that they are giving us is mass, length, and force. So first of all, we need to know the constant of mu, and we divide the meters times the length over the length, and it gives us 1. Then we substitute our values in the velocity formula, that is the square root of force over the mu, and we divide them, and this is the velocity. In problem number 5, they are asking us for the mass. First of all, we have our data, that is length, force, and velocity. We need to clear out, first of all, we need to clear out for mu. We use the formula of velocity equals to the square root of the force over the constant. We substitute the data that we have, and then we clear out for mu. We divide the force over the velocity, and when we got mu, we need to clear out for the mass with the formula of the constant, that it's mass over length, and we pass the length multiplying, and then we have the mass. In problem number 6, they are asking us for the time. First, we have our data, that is density, the Young modulus, and first of all we need to know the velocity. So we use the formula of square root of Young modulus over the density. We substitute the values that we have, and then we have the velocity. Then we use a rule of 3, because we have that 300,646 0.29 meters per second. In 1 second, the sound have this distance. So how much will be in 2.5 meters, and we have the time. In problem number 7, they are asking us for the intensity. First, we have our data, that is 55 decibels and the intensity at 1000 hertz. So we use our formula of 10 logarithm intensity over the intensity at 1000 hertz. First, we substitute our values, the belts, and the intensity at 1000 hertz, and then we pass the 10 dividing, and this we multiply them to the intensity, and we pass the -12 to positive. And because the logarithm is the inverse of the exponential functions, we put our base to the 10, because it's a base 10, and then we pass this 10 dividing, and we have the intensity. In problem number 8, they are asking us for the frequency of the listener that is moving away and that is approaching a source. So we have our data that is the frequency, the velocity, we change it to meters per second, and we use this formula that is velocity of the air at a normal temperature, the frequency source over the velocity plus or subtract the velocity source. Here is when it's moving away, and we have the frequency of number 1, we substitute our values, and in frequency number 2 we substitute our values. Instead of adding, we are going to subtract the velocity source, and we have frequency. In problem number 9, they are asking us for the frequency of the listener when a source is moving or approaching. So we have our data that it's velocity in kilometers per hour, so we're going to change it to meters per second. Then we have the frequency, and we are going to use the formula of the frequency of the listener, that is velocity of the air at a normal temperature, that is 343 meters per second. The frequency of the source over the velocity of the air, adding or subtracting the velocity of the source. We substitute our values, and we are going to put in one part we're going to use the positive sign because the source is moving away, and here we have the frequency, and then we're going to use a negative sign because it's approaching, and we have the result.